Let us discuss one more example of indeterminate form of the type infinite minus infinite. Example, evaluate limit x tends to 0, 1 upon x minus 1 upon sin x. We have limit x tends to 0, 1 upon x minus 1 upon sin x. Given that x tends to 0, if we put x equal to 0 here, 1 upon 0 is infinite. So first term is infinite, minus sin 0 is 0, 1 upon 0 is infinite. So second term is also infinite. So it is infinite minus infinite form. To evaluate this limit, we convert this term into 0 by 0 or infinite by infinite. So for that, take cross multiplication, limit x tends to 0, sin x multiply here, sin x minus x multiply here x, and denominator is x multiply by sin x, so x sin x. Again we put x equal to 0, sin 0 is 0, this term is 0, so numerator is 0. And denominator 0 sin 0, that is also 0. Now it is 0 by 0 form. So we apply L'Hopital rule, differentiate numerator and denominator. Before that, we simplify this term. We get limit x tends to 0, sin x minus x, divide by, here we multiply by x, we get x square. And here we divide by x, that is sin x by x. Because we know that limit x tends to 0, sin x by x is 1. So we get limit x tends to 0, sin x minus x, divide by x square, and this limit is 1 as x tends to 0. It is still 0 by 0 form, sin 0 is 0, this term is 0, denominator is 0, so we get 0 by 0 form. Now we differentiate numerator, so limit x tends to 0, differentiation of sin x, that is cos x, differentiation of x, that is 1, and differentiation of x square, that is 2x. Again put x equal to 0, cos 0 is 1, 1 minus 1 0, numerator is 0, and denominator is 2 into 0, that is also 0. It is 0 by 0 form. Again we apply L'Hopital rule, again differentiate numerator and denominator separately, so we get limit x tends to 0, differentiation of cos x, that is minus sin x, differentiation of 1 is 0, differentiation of 2x, that is 2, and now we put x equal to 0, sin 0 is 0, 0 divided by 2, that is 0. So we get the limit, this limit as 0. This is the method how to evaluate the indeterminate form of the type infinite minus infinite.